Explore the working production process of modern machines, where automatic machines and lines turn out convenient products with precision and power. The metal bending process begins by positioning a large structural steel profile into the Derma PBH 600 profile bending machine. The operator carefully aligns the profile with the rollers before activating the machine. In the first pass, the rollers apply controlled pressure to initiate the curve, aiming for an internal diameter of approximately 12,000 millimeters. The process involves multiple progressive passes to achieve the desired curvature. In the second pass, the operator adjusts the position of the profile and further engages the bending rollers, increasing the curve depth slightly. After each pass, the operator visually inspects the profile's curvature and manually measures key parameters to ensure consistency with the bending plan. The third pass follows with deeper penetration by the top roller, gradually forming the arc without causing structural deformation. Subsequent passes 4th, 5th, and 6th continue the incremental bending. With each pass, the operator repositions the profile, monitors the radius, and adjusts roller pressure as needed. The process emphasizes precision and repeatability, avoiding overbending or flattening. Throughout the operation, the machine's hydraulic control system ensures smooth, even movement of the rollers, while the heavy-duty frame stabilizes the profile. The gradual, multi-step approach allows tight control over the internal diameter and profile shape. By the final pass, the profile achieves a smooth, uniform curvature consistent with the required ID of 12,000 millimeters, demonstrating the capability of the Derma PBH 600 to handle large, heavy-duty profile bending tasks effectively. The cutting process begins with placing a large white roll of disposable medical bedsheet material onto the working surface of the customized cutting machine. An operator manually adjusts and feeds the roll into the machine's cutting area. The machine is equipped with a sharp vertical blade that slices through the roll with precision. As the blade cuts, the material is divided into smaller sheets or blocks according to the desired dimensions. This step ensures that the material is shaped or sectioned properly for further processing or for immediate use as finished products. The cutting is done cleanly and efficiently, allowing high throughput and maintaining consistency in product size and quality. The blow molding process begins with plastic material being melted and extruded into a large parison. The mold then closes around the parison, and compressed air is blown inside to expand it into the shape of a 5,000 L water tank. After cooling, the mold opens, and the formed tank is removed. Excess material is trimmed, and the finished tank proceeds to inspection. The machine can produce tanks from 1,000 L to 5,000 L in up to 6 layers, with a daily output of 96 to 120 pieces. The 4-axis tufting machine secures the hockey-shaped toilet brush handle, then drills holes and inserts bristles in one continuous process. The rotating head moves precisely along the brush contour, placing each tuft accurately. Finally, the machine finishes the tufting cycle and releases the completed brush head. The round toilet brush is clamped in position. The 4-axis tufting machine precisely inserts tufts into pre-drilled holes using its single tufting head. The brush rotates and tilts automatically, allowing the machine to complete tufting across the entire curved surface with consistent spacing and alignment. The cleaning process of the back patio began with the removal of a rug that had been heavily soaked with pet urine. Underneath the rug, there was a thick buildup of urine residue on the concrete surface. To address this, the area was pre-treated using EBC Restore, a powerful degreaser and cleaner. The solution was applied generously and allowed to dwell for about 15 to 20 minutes to break down the organic waste. After the dwell time, the cleaner applied a mixture of 2 to 3 cups of bleach using a bug sprayer to further sanitize the surface. This was only done in the open patio area. Inside the garage, which is an enclosed space, an enzyme cleaner was used instead to avoid leaving harmful bleach fumes that could pose a risk to anyone entering the area later.
Those fumes, whenever the builders came back the next morning, I didn't want them exposed to that. So one thing I want to...
The objective of this task was not to restore the patio to a like-new condition, but to eliminate pet waste and odors to prevent the property from being classified as legally uninhabitable due to health concerns. Therefore, specific cosmetic issues like grill marks or rust stains were not addressed during this process. After pre-treatment, surface cleaning was performed using a pressure washer with hot water. The operator checked the effectiveness of the dwell time by rubbing the surface with a gloved hand. If residues came off easily, it indicated the area was ready for pressure washing. A custom-built cart was used to assist during the cleaning. The job concluded with a thorough surface wash, effectively removing all pet-related contamination. Fill the Cougartron Pro Plus with cleaning fluid. Attach the weld brush. Connect cables and earth clamp. Set appropriate amperage, then move the brush across the 316 stainless MIG weld, dissolving heat tint. Rinse with neutralizer, wipe dry, and inspect the bright, passivated finish. The 4-axis CNC machining process begins with securely clamping the wooden sofa leg blank onto the rotary table of the Tormat Joker machine. The spindle performs rough cutting along the length of the leg using a rotating tool. Then, the rotary axis turns the workpiece for multi-angle profiling. The machine continues with fine contouring and surface smoothing along all sides. Decorative grooves and round edges are precisely milled. Throughout the process, the CNC system synchronizes tool movement and table rotation to achieve consistent shaping. Finally, the leg is automatically released, completing the precise and efficient multi-face machine. The process begins with placing the Rhino RX7 concrete grinder on the extremely rough Elasticrete terrazzo countertop. The operator uses both hands to guide the lightweight, handheld Planetary grinder across the surface in slow, overlapping passes. The grinder's multiple rotating heads evenly abrade the surface, cutting through high spots and exposing the embedded terrazzo aggregate. Fine dust is continuously extracted by a connected vacuum system to maintain visibility and cleanliness. The operator maintains consistent pressure and movement, adjusting grip and angle to reach edges and corners thoroughly. Several passes are made to ensure a uniform grind, gradually leveling the uneven surface. The embedded terrazzo chips become increasingly visible and evenly exposed as the grinding progresses. The session ends with a noticeably flatter, smoother surface, preparing the countertop for finer polishing stages or further surface treatment. The operator uses the Rhino RM150 for wet grinding, continuously spraying water onto the surface throughout the process. As the machine moves over the concrete, the rotating grinding head smooths the material, while water controls dust and cools the surface. This consistent wet application enhances the grinding efficiency and finish quality. The cartridge forming process begins with the MCA tube loader, which automatically feeds pre-cut cylindrical tubes into the production line. Tubes are aligned and individually positioned into loading chutes, ensuring continuous and precise delivery to the forming unit. Next, the tubes enter the GS 36/3 triple exit forming machine, a high-speed system designed for simultaneous neck and bottom forming. The machine is equipped with 36 upper chucks dedicated to neck forming and 30 lower chucks for bottom forming. As the indexing table rotates, each station performs a forming operation. 3 cartridges are formed with every index movement, allowing for high output rates. The upper chucks apply downward force to gradually taper and shape the tube neck using precision dies, while the lower chucks support and shape the cartridge bottom, often by pressing or flanging. This dual-action process ensures dimensional consistency and high forming accuracy. After forming, the cartridges are transferred to the Novus Dimensional Inspection Station. This station utilizes sensors or contact probes to measure critical parameters, such as neck diameter, wall thickness, and total height. Cartridges that fail to meet tolerance limits are automatically rejected to maintain quality control. The accepted cartridges then pass through the ALS 6TRC afterforming line, which may involve further mechanical adjustments such as trimming, flange resizing, or stress-relieving operations to correct minor deformations from forming. Following this, the cartridges move into the ALS 7FT annealing layer, a heat treatment furnace where they are subjected to controlled heating and cooling cycles. This process relieves residual stresses and improves metallurgical properties such as ductility and hardness, essential for downstream processing. Finally, cartridges undergo a cleaning stage to remove lubricants, oxides, or forming residues. They are then subjected to cosmetic inspection, where high-resolution cameras or operators identify surface defects. Only flawless cartridges proceed to packaging or further manufacturing. The operator feeds the rebar into the semi-automatic cutter's guide, ensuring precise alignment. Once positioned, the guide activates the hydraulic control system, which commands the blade to engage with the rebar. The rebar is cut cleanly, using hydraulic pressure, resulting in precise, burr-free cuts. After cutting, the machine retracts the blade and automatically places the next section in place. The operator visually inspects each section for quality, then manually removes it. This efficient, repeatable cycle of feed, cut, advance, and remove allows for rapid processing with minimal manual effort, improving productivity and ensuring consistent, accurate lengths every time. The AMECO trapezoidal roofing roll forming machine begins by feeding steel coils into the entry section. The material, guided through rollers, is progressively shaped into rib-type roofing panels as it passes through 18 to 24 forming stations. The machine forms panels from coils 914 to 1,450 millimeters wide and 0.2 to 0.8 millimeters thick. Driven by gear motors or hydraulics with inverter control, the system ensures consistent shaping. After forming, a hydraulic cutting unit trims the sheets to preset lengths with a tolerance of plus or minus 2.0 millimeters. The finished panels exit the machine, ready for roofing installation. The Thibaut Deep Hole Drilling Machine Type E, the 2nd of October 375, performs high-precision drilling of bone screws. The automatic loading station feeds the workpieces into position. Twin spindles simultaneously drill holes with diameters from 2 to 10 millimeters. During operation, the rotating tools advance steadily into the material, reaching depths up to 375 millimeters. Continuous coolant flow flushes chips from the cutting zone and ensures thermal stability. Once drilling is complete, the spindles retract, and the automated unloading system removes the finished screws. This synchronized process enables efficient, repeatable production of deep holes with excellent surface finish and straightness. The vertical double-sided milling process using a CNC double-head face milling machine. First, the operator positions a rectangular workpiece between two vertical milling heads. Once clamped, the automatic system activates simultaneous face milling on both vertical sides of the workpiece. Each pass removes 2 to 3 millimeters of material from both faces. The machine operates under heavy cutting conditions, ensuring precise and efficient metal removal. After the first pass, the machine retracts slightly and a second pass may follow to achieve the desired surface finish. Throughout the process, automatic measurement ensures dimensional accuracy. The rigid HT300 cast bed provides high stability and reduces vibration, which contributes to consistent machining quality. The machine supports workpieces ranging from 20 to 430 millimeters in length and 200 to 1,200 millimeters in width, with a maximum thickness of 190 to 290 millimeters. The use of rotary index tables, sized from 330 x 300 millimeters to 800 x 800 millimeters, enables precise positioning and handling of parts. This setup ensures high productivity and precision in machining, hydraulic manifolds, dies, and large blocks. The manufacturing process begins with the preparation of 4 identical metal blanks. These blanks can be either square bars with dimensions of 6 by 6 millimeters or 8 by 8 millimeters, round rods with a diameter of 6 millimeters. First, the operator selects the correct mandrel set according to the chosen material size. Then, the 4 blanks are inserted into the rotating mandrel of the machine, evenly spaced around a central shaft. Next, the operator slowly rotates the handle, causing the mandrel to twist the 4 rods simultaneously around the shaft. As the rods wrap around, they form a smooth, symmetrical spiral. The twisting continues until the required shape is achieved. This step forms the basic curved components of the decorative basket. After the twisting is complete, the rods are removed from the mandrel. Then, the operator proceeds to the assembly stage. The twisted components are carefully positioned inside a dedicated conductor frame. This frame aligns the parts in a way that they intersect to form a basket shape. Once properly aligned, the operator uses spot welding to join the contact points between the rods. This ensures the shape is rigid and stable. The finished product is a welded forged basket, ready for Decorative. Following the basket fabrication, the tool is used for longitudinal twisting or torsion. For this, the operator selects a square bar up to 16 by 16 millimeters or a flat metal strip, such as 20 by 4 millimeters. One end of the bar is clamped securely, while the other end is rotated using the handle. As the bar twists, a consistent helical pattern is formed along a 500 millimeters section. In addition to single bar torsion, twisting two bars simultaneously. First, two square bars of 8 by 8 millimeters are placed side by side and twisted together to create a decorative double helix. Then, the same operation is performed on two round rods with a diameter of 8 millimeters. In both cases, the tool's long handle provides mechanical advantage, allowing the operator to twist the materials with minimal effort. Overall, the M04 WKR tool simplifies the process of forming baskets and torsioned elements. With its interchangeable dies and guiding frames, it enables fast, repeatable, and accurate production of artistic forged elements, even for users without blacksmithing experience. During the test run, the mechanical cross-screen XS begins operating as the rake bars move stepwise to capture solid debris. The screen continuously lifts and removes the waste using a reciprocating motion. As the grid cycles, materials are efficiently separated from the water flow. The mechanism runs smoothly, demonstrating effective screening performance during operation. Using the Rhino hammer by Slap Pro, the operator effortlessly separates laser-cut parts from the raw sheet by striking them. This method reduces worker fatigue and injury risk while significantly saving processing time. The staple packing process begins with staple strips being automatically fed into the machine. A conveyor aligns and transports the strips into a counting section, where the machine precisely counts a fixed number of strips. Once the correct quantity is gathered, the strips are pushed into a forming area, where packaging film is shaped into a pouch. The strips are then inserted into the pouch. Immediately after, the pouch is sealed from the bottom and sides using heat sealing mechanisms. Following this, the sealed pouch is cut from the continuous film. Finally, the packed staple pouch is ejected onto a conveyor for collection or further packaging, completing the automated process efficiently. The CNC tube bending process with the Wafios BMZ12 begins with automatic tube feeding into the machine. Next, the clamping unit secures the tube firmly in place. The bending head then precisely rotates and bends the tube according to the programmed 2D or 3D geometry. Multiple bends and rotations are performed in sequence, with the servo-driven axes ensuring accurate angles and positions. After each bend, the machine automatically repositions the tube for the next bending operation. Throughout the process, the system maintains high repeatability and precision. Finally, the finished part is smoothly ejected, completing the automated cycle efficiently. A coil of metal wire is fed automatically into a high-precision CNC 3D bending machine. The system grips and rotates the wire, executing a pre-programmed sequence of bends. Specialized tooling shapes the wire in multiple planes, creating complex three-dimensional forms with millimeter accuracy. Sensors provide real-time feedback, ensuring consistency and correcting any deviation instantly. Once bending completes, the finished component is carefully inspected, trimmed, and prepared for assembly or packaging. This automated 3D bending technology delivers high efficiency, repeatability, and precise wire-form products. The paper tubes are automatically loaded from a floor hooper into the cutting unit. The twin-knife air-operated cutting system then slices the tubes on a hard mandrel with high precision, achieving up to 300 cuts per minute. The system ensures accurate and clean cuts within plus or minus 0.2 millimeters. After cutting, the machine automatically selects and separates the trims. The cut rings are then collected and boxed using an integrated auto-boxing system. All processes are synchronized with the recutting machine to ensure continuous and efficient operation. The Truking high-speed Ampoule compact line is a fully automated and integrated solution designed for the efficient production of pharmaceutical ampoules. This advanced system combines washing, sterilizing, drying, filling, and sealing processes into a single, seamless operation, offering a compact footprint ideal for cleanroom environments. Its modular design allows for flexible integration into existing production lines, optimizing space utilization without compromising productivity. Engineered for high speed and high throughput performance, the line significantly enhances production capacity while ensuring product quality and consistency. It features state-of-the-art servo and robotic technology that reduces vibration and glass breakage, resulting in smooth and reliable operation. The filling system is equipped with high-precision dosing mechanisms, such as volumetric or peristaltic pumps, and includes automatic dose adjustment with real-time feedback to maintain filling accuracy. To ensure product sterility and hygiene, the system includes advanced cleaning in place and SIP, sterilization in place functions. Truking also offers containment solutions such as ORABs, CRABs, and isolators that meet OEL 5 safety standards, protecting both operators and products during critical operations. The user-friendly control system features an industrial PC interface with audit trail capabilities, data integrity management, graphical diagnostics, and remote access for enhanced monitoring and control. Compliant with GAMP, CGMP, and FDA 21 CFR Part 11 standards, the line meets global regulatory requirements. By automating all key steps, the Truking Ampoule compact line increases efficiency, reduces manual labor, minimizes errors, and lowers production downtime. It is also customizable to meet specific customer needs, making it an ideal turnkey solution for modern pharmaceutical ampoule manufacturing. The Apurva IME C28 forms tea bags using knotting instead of staples. The tea is fed through a vibrating system, filled into filter paper, and shaped into bags. Threads are knotted automatically, followed by tag and envelope attachment. Finally, the sealed bags are counted and discharged for collection or cartoning.